In this section, I'm going to give us an introduction to paired data and how we do treatments, just to sort of help you get it into your head a little better. Start off in the first frame with something first cell with something we're very familiar with. We're going to import NumPy as NP, import pandas as PD, and then import scipy.stats as stats. So I shift and I enter, and goes around and around. There we go. It's loaded. Now we're going to take a sample. I'm going to take a sample of size 50, and I'm going to be sampling a population where the average is 250 and the standard deviation is 10. Again, our sample size is 50, and we're going to be sampling a normal random variable with the mean 250 and the standard deviation 10. And then I'm going to take it and put it into a data frame. Okay, the data frame created as we so often do from a dictionary. Here the dictionary just has one entry to it, so I shift and I enter. Okay, so I now have a sample, and so I want to think about this like I am applying a weight reduction treatment to a group of 50 randomly chosen individuals with an average weight of 250 pounds. Okay, and so in this cell I'm going to first create a function that will simulate what our treatment is meant to do. So we mean the treatment to actually reduce the weight by 10%. So we're going to take 0.9 times the weight on the average. There will be variation in this. We're going to set the variation to be at 0.10. Okay, so any item that goes into this will be multiplied by a random item, but that random item will be on the average about 0.9. Okay, and then we take that treatment function and we're going to apply it to the weight of the people in our study, the people whose average weight will be 250 pounds. Okay, and so we'll call that the treated column. Okay, now since this is random, it is possible that for some of our treated individuals the weight will go up. We can play with this to show whether it will happen. Here, more than likely the weight will go down. Okay, and we're going to call the effect here, okay, the sample minus the treatment. Okay, and we're setting up the effect so that if we do lose weight, so if our treatment does work, the difference will be on the average positive. Okay, so this is what we're going to do so that we can conduct this hypothesis test the same way every time. Okay, because our hypothesis test, our null hypothesis, since we're setting this up as a scientific test, our null hypothesis is that our treatment doesn't work. Okay, and we'll have to prove our alternate hypothesis that our treatment does work, that our treatment does affect a net loss of weight, which in this case is the sample minus the treated should on the average be positive. Okay, we're going to do this with a significance level of 0.02. Okay, which is there's only 2% chance that if we reject our hypothesis, our null hypothesis, that we're wrong. So if we state that our treatment has worked, we're 98% right. Okay, and we'll use this significance to calculate our critical number. Again, our stats.norm.ppf percent point function of 1 minus the significance will be our critical number because this is a one-tailed test. Okay, so let's shift and enter. Okay, and again, set up our test criterion where we take in, we'll take in the mean, we'll take in the standard deviation, we'll take in the sample size. We compute the standard error of the mean by our standard formula. And then we'll calculate our test statistic from that. Okay. And finally, we will set to reject if the test statistic is positive. If our test statistic actually is greater than the critical number, it will come back true to reject. So I get these functions and I shift and I enter. And next we're going to do calculations. We're going to see whether our treatment worked. I've got x bar is equal to the mean of the effect, and standard deviation is equal to the standard deviation of the effect. And so we'll plug these numbers into the test statistic along with the test size, the sample size, and then we'll plug our TS and our critical number into the reject function. So I shift, I enter, and of course I get an error. Okay, I get an error because while I was talking I forgot to apply the treatment. Okay, so I shift and I enter and I apply the treatment, and now I go back and I shift and I enter, and hey, there we go. I get a true here. Reject because my critical number is, my test statistic is greater than my critical number. And it's always good when you put so many things in functions, you're not doing this by hand, things are hidden in a function, you want to validate your function, so it's good just to take a look. So here in this line I've chosen to reveal the test statistic and the critical number, and so I go shift enter, and well, yes, my test statistic is larger than my critical number.